Hi, in this lecture, we are going to talk about iterators and using an iterator to iterate through a collection. Now, this basically the iterator is an interface from the Java class library. All right, and what is it? An iterator is something you use to iterate through a collection object. Now, when I say collection, I mean uh, it can mean an array list, it can mean a list, a linked list, it can mean a set. All right, basically an object which represents several elements. Now, an iterator is basically represented by a pointer, something like a pointer. I use double quotation marks here. So the pointer is placed just before the first element in the collection. That's the initial start point. And then as you call the next method of the iterator object, the pointer will move to the next element. Now let's take a look at the API documentation. The iterator interface belongs to the java.util package. So remember to import java.util.iterator or java.util.star when you want to use an iterator object. Now, if you are not sure what is an interface, um, this will be covered in detail in the lectures on inheritance. For now, you can just treat an interface as something like a class. It's not really a class, but something like a class, right? So, interestingly, and it's nice that an iterator interface has got only three methods: hasNext, next, and remove. So very easy to use. The hasNext method returns true or false depending on whether there is a next element in the underlying collection, which we are going to iterate through. The next method does two things. Okay. Now the next method does two things. It moves the pointer to the next element, and then it returns that element. So it is very important. It is useful for you guys to call hasNext to check if there's a next element before you call next. Why? Because if you call next and there's no more element, no more next element, it will throw a no such element exception. So to prevent that from happening, you might want to call hasNext. Only when hasNext returns true, then you call next. Now hasNext does not shift the pointer at all. Otherwise, it is possible that calling the next method will cause a no such element exception. Right? And the last method is the remove method. The remove method is called to remove the element which the iterator is pointing to currently. All right, from the underlying collection. Now a bit fuzzy. Let's take a look at an example, and things will be very much clearer. So I have this iterator example here. In the main method, I've created an array list called flavors on line 6. It's an array list of string objects. Okay, for those who haven't gone through the lectures on inheritance, you'll be wondering why is flavors declared of the using the type list instead of array list. It doesn't matter. If you want, you can do this. Okay, but after the lectures on inheritance, you'll be very clear that this is actually possible. Okay, I'm not going to talk about that here. So flavors contains the address of an array list object, and from line 7 to 10, I'm going to call the add method of the array list to insert 4 elements, okay, 4 strings into flavors. I'll call flavors.size. This should return 4, and I'm going to call this method called print all flavors and pass the array list to print all flavors. Here it is print all flavors. It takes in an array list or a list object. Now, the list object has got a method called iterator. The list object okay, this one, has got a method called Iterator. Here it is. Very useful method. Basically, it returns an iterator object, which has got the next, has next, and remove method. I will check if this is true. Okay, remember what I said just now. At the very beginning, the pointer for the iterator is placed just before the first element in the collection. So diagrammatically, it's going to look like this. The pointer will be pointing at the spot just before the first element. Now, in this code example, let me go back to the source code. I can't remember. Chocolate, strawberry, vanilla, durian. Okay, chocolate, strawberry, vanilla, durian. There are only 4 elements, so I shall remove this. There are only 4 elements in this array list. So this is the starting point, the starting state. When I call has next of the iterator, it returns true because there is the next element. Okay. I go into the while loop and I call the next method. Remember, what does the next method do? The next method does 2 things. It updates the pointer so that now it points to the first element and it returns the element it is pointing to. So it returns the string chocolate, which gets printed out here. Okay, go back to the while loop. Has next returns true. Okay, I call iter.next. So now the pointer gets updated. And it returns the strawberry string, which gets printed out. I call hasNext again, which returns true. Ether.next shifts the pointer to the third element, returns vanilla, okay, which gets printed out here. And the last, it calls hasNext again, which returns true. It calls Ether.next, it returns durian, the string durian, which gets printed out. And the last time it calls hasNext, look at the diagram, it's quite obvious that there's no more next element. Hence, this will return false, and I'll get out of the while loop. So let me compile this piece of code, iterator example, and run it. Okay, not surprising. Let me give another example. Okay, I've written another print all flavors method, same name. These are overloaded methods. Remember what are overloaded methods? Methods of the same name, the same class, but they take in different parameters. Now the second print all flavors method takes in an iterator object. The while loop is the same, identical. So the only difference here is that when you call print all flavors, the second one, you need to pass in an iterator object. So in order to invoke the second print all flavors method, I've passed in an iterator. Remember, the array list or the list object has got the iterator method. So just by doing this, I'll be calling the second print all flavors method. Okay, if I compile this, save this and compile this, the output will be exactly the same. Okay, it's just that now the second method is being called. Now what I'm trying to show you, I'm just trying to show you 2 examples. So a method which takes in a list, okay, and a method which takes in an iterator object. Okay, both are fine, depends on which one you prefer, which one you want to use. Now, I mentioned just now that an iterator can be used to iterate through a collection. The example I've shown here is an array list. Okay, most other collection objects will also have an iterator method, which returns an iterator object, which you can use in a similar way. So let me show you an example, a hash map example, hash map iterator example. I've created I've created 5 person objects. I've created a hash map here called map, and I have used the put method to actually insert these entries into the hash map. Now, the hash map has got a method called keyset. Which returns the list of keys. Keyset is here. Which returns the list of keys in the hash map as a set object. Now, if you click on the set object here, you realize that the set object has got an iterator method as well, which returns an iterator. In this case, an iterator of strings, because the key for my hash map is actually a string. Very useful. Okay, so I call the keys.iterator method, which returns an iterator object. Okay, I call it ether ID. You probably want to choose a better name. And this iterator object can be passed to a method which is similar to the print all flavors method, except that now I call this print all elements. We're not dealing with flavors here, which takes in the iterator object and if call the hasNext and next method and print out. You can do whatever you want with the underlying current element here. So see the usefulness of the iterator. It does not matter what collection object you are dealing with. You can be dealing with a set object. You can be dealing with, in this case, you can be dealing with a array list object. As long as that collection object provides an iterator method which returns an iterator object, you'll be able to call the hasNext, the hasNext, the next, and the remove methods. If you check out the hash map again, okay, besides keyset, there's also another method called values. Here it is. Now, values return a collection object. If you check the collection object, you realize that it also has an iterator method, which returns an iterator. So it's really easy. You do not have to bother as to what are the methods in a collection object. You do not have to bother what are the methods in a set object. You don't have to bother about what are the methods in an array list object. As long as you get hold of the iterator to that collection, you know how to use it by calling the hasNext, the next methods. Alright, if you really want to remove an element, you can call the remove method. So I've shown you an example here, which brings us to the last point here. Why do we want to use an iterator? Because using an iterator decouples the iterator from the underlying collection object. Like what I mentioned just now, you do not need to be familiar with the collection object to iterate through it. You don't have to bother what are the methods in set, the methods in collection, the methods in array list, in order to move from the first element to the second element to the third and so on to the last element. Once you have the iterator, you just use hasNext and next to move from the first to the last element. Okay, so it gives a very independent and standardized way of going through a collection. If you want to write a collection class yourself, and you want to provide the same convenience to users of your collection class, all you have to do is to provide an iterator method which returns an iterator object, so that whoever uses your collection object won't need to be familiar with the methods you provide to iterate through the collection. They just have to be familiar with the iterator methods. Okay, there are only 3. So that's all.